So when we talked about this on Thursday, we had done one type like this here, where we had two logs being added together. And we noted that our properties of logarithms stated that log base b of m times n is equal to log base b of m plus log base b of n. And it also works out if we have two logs with the same base being added together, we can rewrite it as one log being multiplied together, of what's inside being multiplied together. So when we look at this problem here, log base 6 of 6x plus log base 6 of x minus 1 is equal to 2, we can rewrite the left-hand side, their two logarithms, as a single logarithm with what's inside both logarithms being multiplied together. So we can rewrite it as log base 6 of 6x times x minus 1, because we need it as one log. Because if I want to simplify log base 6 out, I need only one of them. I can't have two. It doesn't work well with two. Any questions on this here so far? Now, how can we simplify log base 6 on the left-hand side? Right, we'd put it as 6 to the log base 6. Because 6 to the log base 6 will simplify. And essentially, we're putting both to the base of 6. Because this right here, 6 to the log base 6 of 6x times x minus 1 will become 6x times x minus 1. That will simplify for us. And on the other side, we're going to have 6 squared. Yes. Then we would distribute our 6x, so we can simplify this a little bit easier. It's going to be a little bit easier to solve once we get rid of those parentheses. Well, 6x times x is going to be 6x squared minus, well, 6x times negative 1 is negative 6x is equal to 36. Yeah, so we can, at this point here, we can divide everything by 6. Because it does work out that there is a greatest common factor of 6 between all three terms. And since it's not a variable, we can go on and divide it out, which will leave us with x squared minus x is equal to 6. Yes, we would want to get this equal to 0. Because we do have a quadratic, we do have a variable x to a degree higher than 1, bless you. We have x squared. We need to get everything on the same side and get it set equal to 0. So here we're going to have x squared minus x minus 6 is equal to 0. Because we need everything on the same side of the equal sign. Any questions on this so far? Factoring. Yes, we can factor this. So we'll have our two sets of parentheses equals 0. Plus and minus. Because this, x and x, yes. Positive 2 and negative 3. Is how we would factor this here. Yes, and x would be negative 2 and positive 3. Because we had set it up as x plus 2 is equal to 0. X minus 3 is equal to 0. Subtract 2 from both sides tells us x is equal to negative 2. Add 3 to both sides telling us x is equal to 3. X minus 1. And if we checked it, and we'll see with negative 2, we'd have log base 6 of, well, negative 2 times 6 would be negative 12x plus log base 6 of negative 3 is equal to 2. But we cannot have negatives inside of the log. That wouldn't be negative 12x. It'd just be negative 12. This does not work. If we do the same thing with 3, log base 6 of 6 times 3 is 18. Log base 6 of 3 minus 1 is 2. And if we plug it in, it will work, and we do have positive numbers. So x equals negative 2 does not work in the original problem. So x equals 3 is our solution, the one that does work. Any questions on any of this here? Let's see here. Because I feel like y'all are getting comfortable with these here, because the only real trick between these and the ones that we did on Thursday, besides the one that was like this, was really that addition property. I do want to look at one more. I don't want to look at both of them. But out of these two here, 7 and 8, which one do you guys want to look at more? I'm guessing 7. We can look at 7. So when we look at 7, what is our first step going to be? To combine the logs. Because log of 5x plus log of x minus 1 is going to become log of 5x times x minus 1. And it's going to be equal to 2.
Oh, I thought you said it.
Right, we would use the 10 because the base for this is 10. Because it's not written, it's understood to be 10. So exactly, we'll have 5x times x minus 1 is equal to 10 squared. We can distribute. 5x times x is 5x squared. 5x times negative 1 is negative, is equal to 100. What can we do next? We can subtract the 100. Yes. On the last one, we went on and divided by, well, we divided by 6 on the last one, and here it would be dividing by 5. Because we can do it before we move the 100, or we can do it afterward. We can do it in either order. It doesn't really matter. So, yes, let's go on and divide by 5. This 5x squared divided by 5 is just going to be x squared. 5x divided by 5 will be x. And 100 divided by 5 is? 0 divided by 5 is? It's a quadratic, so we would factor it. Yes. 2 sets of parentheses. X and x. Yes. Yes, so we would subtract 4 from both sides. Add 5 to both sides, which tells us x is equal to 5 and x is equal to negative 4. And plugging it back in, we would see that x equals negative 4 does not work. Because when we look back at the original problem, the first one is log of 5x. Well, 5 times negative 4 would give us log of negative 20. We cannot have a negative inside of the log. So it does not work. It would not be one of our solutions for this here. Any questions on any of this here? Okay. So the only other thing that we're going to cover in 6.62 is inequalities, solving exponential and logarithmic inequalities. Now, the way that we solve exponential inequalities is going to be the exact same as we solve exponential equations. When we get to logarithms, we'll have to be careful about the sign and how it works out. But with exponential inequalities, we don't have to really worry about any restrictions. Because where the x is in an exponent, 3 to the x has no restrictions. X can be positive or negative. We can put any number into that exponent. And as we've seen already, we can have decimal numbers. We can have really ugly decimal numbers in the exponent. And that works perfectly fine. But we know inside of logarithms, we cannot have negative numbers. So we'll have to look at some restrictions if they do show up. But for this here, what do you think we could do first? If y'all were to take a guess, what would y'all guess? Well, let's change that. If this was this here, what would we do? I can't subtract 3 because it's connected with that x. Because what did we do on Thursday? It involved logs. Log base what? Because our log base 3 of 3 to the x, well, according to our properties, the x would come out front, really telling us that I have x of log base 3 of 3 is less than log base 3 of 20. Now, whenever the base and the number at the side of the logarithm are the same, this here just simplifies to 1. So really what this is telling me that x is less than log base 3 of 20. Any questions on anything we've done so far? Now, is log base 3 of 20 a number? Can I get a value for log base 3 of 20? Yeah. So let's go on and plug it in and see what we get. Because if we round it to 3 decimal places, we'll get 2.727. And that's it. So I know you've slept between now and last Thursday, but is this really any different than what we did last Thursday? No. And these here will be the exact same as our equations, except if we multiply or divide by a negative. Because the properties of inequality state that if we multiply or divide both sides by a negative, we have to change the sign. We have to change the sign. And that's really going to be the only difference. Bless you. Bless you. Yes. But, yes. Now, that is correct. There is nothing wrong with saying log base e, but ln is the log with a base of e. It's understood. And I think it's coming more from the fact that they do not like having this base or kind of written as an irrational number. They want to use logs for more rational numbers, but that's just a guess. And as we saw last week, ln of e simplifies to 1, leaving us just with our x, because the x does move out front. Right about here. Equals ln of 2. This point here, we just have to type in ln of 2. 0.6931. 0.6931, or if it wants 3 decimal places, 0.693. Either one of these will work. Any questions on any of this here? Okay. Right. So we'll look at this one here. I was just looking ahead and see what we have. It would be log of 10. And if it is 10, it's a common log because the base of logarithms is understood to be 10 unless it's written otherwise. So writing log base 10 of 10 to the 2x minus 6 or just writing log are the same thing. Now, will big ideas count it wrong if you do log base 10? Probably, because it's a nitpick. But I won't count that wrong because that is the same thing. Because it's the same as writing 1x. We understood it's 1x and x are the same thing. It's not wrong to write it that way. Now these here will simplify, leaving us with 2x minus 6 is greater than log of 3. Now when you do these calculations, especially with natural logs and logs, it's good when you type it into the calculator to have the parentheses around the 3, just so we make sure to get the right calculations. Now, is x by itself? No. So what do we need to do first? I would add 6 first. And I'll come back and show the division of 2 because it does work out. Well, it's not the 3. There's something different. I'll show it here in a minute. Because we would add 6 first. I would add 6 first. And then we would divide both sides by 2. Which would tell me that x is greater than log base 3 plus 6, or log of 3 plus 6 divided by 2. Any questions on any of this here so far? And I believe it's going to take you to 3 decimal places, which would be this here, 3.239, because it's 3.2385. So we would round up. But are there any questions on any of this here? Are we good with this here so far? Okay. Now I want to go back. I'm going to erase all this here. Scroll back up. 6. Okay, so we had minus 6. Now, it is not wrong, it's not technically wrong, to divide by 2 at this point here. That's fine. And here it actually doesn't work out too bad. Because if we do this division of 2, well, 2x divided by 2 is just going to be x. 6 divided by 2 is 3 is less than log base 3 divided by 2. And at this point here, we can add 3 to both sides, which would give us x is greater than log of 3 divided by 2 plus 3. And this here, if we actually typed it in, we'll get the exact same thing. We should 3.239. It'll actually give us the exact same value. The reason I'm hesitant to use this here is especially when, let's see here, highlighter. These here, because log of whatever it is not going to be divisible by 2. It just doesn't work. Because it can be, but we'd have to rewrite it as a fraction out front and then pull it up into an exponent. A little bit more steps, a little bit more to do. But I'm more focused on the -6, because if this is an odd number, then I have a fraction that I have to add to both sides. It makes it a little bit more challenging. So we really want to try to get the variable by itself first before we start dividing. It's not wrong to do it before then, but I normally wait until I absolutely have to. Any other questions on this here? Okay. So we want to solve a log of x is less than or equal to 2. Now I've been going back and forth on how, there's one part of this that I've been going back and forth on how I want to approach it, and I think I've come to a conclusion. We'll see how it works on this here. Now the overall process of what we're doing is not going to change. There's just one slight detail we have to add in. Now what do we know about x? What can x not be? It can't be a negative number. So with equations, even if we got more than one answer, well, it was definite we can easily check the ones, check all of them and see either yes, they do work or no, they don't. But with inequalities, we're talking about a range of numbers. So we do have the possibility that depending on how the sign works, to have negative numbers included. So we have to make restrictions. So in years past, I've gone through and we've figured out the restrictions first, but we'll figure them out at the end if they are needed. So if this was an equation, well, as we've seen already today, we would kind of put both of them to the base 10. Because the fact that since we have log of x, well, 10 to the log of x, well, the 10 in the logarithm will simplify out, leaving us with just x is less than or equal to what? So we have this here. Does this inequality include negative numbers? Is -1 less than or equal to 100? So does this here, x is less than or equal to 100, does it include negative numbers? Well, yes, it includes all of them because every negative number is less than 100, yes? Okay. This is the case, and this is what I was going back and forth on doing first. So what we're saying, what is inside the logarithm? The values of x, after it's simplified all the way down, cannot be less than 0, yes? So what we're saying is what's inside the log has to be greater than 0 or equal to it, yes? So what is inside the logarithm? X, because that's the only thing inside the log here, yes? So what we're saying is that x has to be greater than or equal to 0. And if here it's just x, even if we have an equation, what's inside of there has to be greater than 0 after we plug x back in. Well, that's done, and x is already by itself. So we're saying x has to be greater than 0. And when we solved it, it is going to be less than or equal to 100, yes? So we have to add this on so that we remove any of the negative numbers that will not work for logarithms. And this here is our answer. Now with exponential inequalities, it didn't matter, bless you, because we can have negative exponents. That's fine. We can have positive. We can have rational, irrational. With exponentials, having a negative or positive number in the exponent doesn't matter. But we cannot have a negative inside the logarithm. That's the big difference. So let's look at this one here. I just changed the problem. I know I did. Yep, I knew I did. I do not like that they don't use parentheses in this book, because really what this problem is stating that we have is this here. We'll do it the other way and see why it makes a difference. But we'll look at this one here. Now, when we worked on the first few, we said we really need to get the log by itself. I can't have more than one of them before we can start using kind of the base 10 to simplify it. We should minus the 9 first. And then we would, because 10 to the 36 is going to be the same as 1.
I'm so tired. No.
That number there. Thousands, millions, billions, trillions, quad, quin, hex, sept, oct, non-dec. So 1 undectillion.
Can I retire from this, please?
Now, we're almost done. When we look at this here, could x be a negative number? So I'm just, because is negative 1 less than 10 to the 36?
Yeah.
Well, yes, because really this is a huge number, so anything less than it is going to be true for this inequality. Now, since x is by itself, because inside the log we just have x, and it has to be greater than or equal to 0, well, we just have this here. Any questions on this here? Okay. Let's be nice. Let's say, okay. I want to do it this way with those parentheses around it. I wanted to change it from 45 so we don't have 10 to the 45th. It's a little bit smaller, a little bit nicer to look at. So the x plus 9, it's all inside the parentheses. Yes. So here we don't have to move anything or do anything with it. We can set both of them to the 10. It is less than 10 to the 4th, which is going to be x plus 9 is less than 10,000. Then we would subtract 9 from both sides. x is less than 9,991. Now, just like with the last one with 10 to the 36, we still do have negatives because it's less than. So we have to set what's inside the logarithm to be greater than or equal to 0, because what's inside the logarithm cannot be less than 0. So we do need to solve this one here because x is not by itself. So what do we need to do? So x has to be greater than or equal to -9. So we can add this in. And this here would be our solution. Because if I plug -9 into that log, well, -9 plus 9 is 0. I can take log of 0. That's fine. Because -9 does work. We do have some negatives that I can plug into this and still get a true statement. But anything less than -9 will not work. Because even if we try -9.1, well, -9.1 plus 9 is -0.1. We have a negative, it does not work. So -9 is the last number we can actually plug in that will still work for this here. Any questions on these here? All right. Two, ln of x minus 1 is greater than 4. Yes, we would add 1 to both sides. Two, ln of x is greater than set everything to the e. Almost. So we would get ln by itself. And once we get ln by itself, then we would use e for these to simplify out, leaving us with x is greater than e to the 5/2. Now, if I have, because e is just a number, yes? E to any exponent, will it ever be less than 0? No, because even if the exponent was negative, it just moves it from the numerator to the denominator, which just makes it a small decimal. Here, we're going to get a whole number value, probably somewhere close to 7, if we typed it in. Or what did we get? 12.182. So we get a whole number, or we get a positive number. It's not going to be a whole number. It's going to be a non-repeating, non-terminating decimal. But would -1 be greater than 12? Well, no. Is there any way that this variable can be negative? No. So our answer for this here is just this. We don't need the restriction. We don't need to see what value of x needs to be greater than 0, because it's always going to be greater than 0 in this case here. And that's why I was going back and forth, because we could have gone through and saw and tried to find what values of x would make this one greater than 0, but there's not a whole lot of point to it because it's always going to be greater than 0. There's not going to be a value where it won't be. Any questions on this here? we're going to stop there for the day. This problem here with cooling and how objects change in temperature is pretty neat. It's an interesting thing, but we're not going to worry too much about it here.